welcome again. After talking about the derivative of logarithmic function from the previous video, if you have watched it, about the properties of differentiating logarithmic function, let us try about this question. This question which is somehow involve other properties. So, like converting from exponential to logarithmics. We have a curve. A curve has equation x, which is equal to 1 over 5 e power y bracket 2x negative 3 bracket 1 plus 4. Then we need to find the value of dy dx when x is equal to 1. So it's like we are asked to find the derivative of this function at x equal to 1. So let's go with the solution. The solution, since we are asked to find the dy dx on this function x equal to 1 over 5 e power y 2x negative 3 then plus 4. What we need first of all, because we are asked to find the y dx, we need to make y the subject from that function. We need to find, or we need to make y the subject. So we need to find y in terms of x first of all, then we differentiate after. So to make y the subject, first of all we need to make a cross product. When we make cross product, we have 5x, which is equal to, we remain with e power y 2x negative 3 then plus 4. So what we can do here, we can take this 4x to this part. When we take that 4x to that part, we have 5x negative 4, which is equal to e power y 2x negative 3. And this is equal to this. This is like e power y 2x negative 3, which is equal to 5x negative 4. And then we need to drop. You see that we have this y and the 2x negative 3 at power, at exponent. So we need to drop it down. We need to bring it down so that we make y the subject. To drop it, we need to introduce ln both sides. We need to introduce ln both sides. So we say that put ln both sides. Because ln is going to help us with its property of logarithms, we are going to have at power can be brought back at the coefficient. So when we drop it down, we will have y 2x negative 3 ln of e, which is equal to when we bring it down, we will have ln of e power y 2x negative 3, which is equal to ln of 5x negative 4. And from this property, this one will be brought down. This one will be brought down. We have y 2x negative 3, which is equal to ln of 5x negative 4. Where this ln of e has gone, this ln of e, when it is multiplied with here, ln of e, it is automatically equal to 1. So it is equal to 1. So there is no need of multiplying it there. So how y is equal to what now? Y as the subject is equal to ln of 5x negative 4 divided with this 2x negative 3. So this is what we have, and this is what we are going to differentiate. We have that y is equal to ln of 5x negative 4 divided with 2x negative 3. That is what we are going to differentiate, and we find the y dx, then we will substitute with the value of x after. Let's come here. So, dy dx is equal to what? When we look here, we see that we have the division. We have the fraction or rational function. The rational function, when we're going to differentiate it, we apply chain rule. When we apply the chain rule, we have this, we assume this as u, while this one is as v. So, u divided with v, derivative, it is u derivative times v, negative v derivative times u divided with u squared, with v squared, divided with v squared. So what you have it up is considered as u, while what you have down is considered as v. So our function now will become, our differentiation now will become dy dx will become what you have up, ln of 5x negative 4, which is derivative times 2x negative 3. We vote derivative, this is u derivative, which is up, times v. We vote derivative, which is this one, which is down. Then we subtract from this formula v 2x negative 3 derivative, which is v derivative, then we multiply with this ln of 5x negative 4, we vote the derivative. We divide with v squared, 2x negative 3 squared. Then, according to the properties of differentiation that we have seen on the previous video, we can say that this is, when we're finding the derivative of ln x, we write 5x negative 4 derivative over 5x negative 4. From the properties of derivative of logarithm, we have that ln of u derivative is equal to u derivative over u. That is the property. That is the property here. So, we multiply with this 2x negative 3. Then, this is negative. Derivative of this is 2 times 1, negative 0. Derivative of 3 is 0, then times ln 5x negative 4. We remember that we divide with 2x negative 3 squared. This is equal to what? Automatically, this is equal to 5 times 2x negative 3. This is 5 times 1 minus 0. 5 times 1 minus 0, it is 5 times this, divided with 5x negative 4. Negative 2 ln 5x negative 4. We divide with 2x negative 3 squared. Now, after this, we need to find a common denominator at up. We have this denominator, and then here we need to have a denominator as 1. So we find the common denominator at the first numerator. The common denominator at the first numerator. When we find the common denominator will be this one. We have 5, 2x negative 3, negative 2, the denominator. If the denominator is 5x negative 4 times this one, 2x negative 3 squared, then it will be 2, 5x negative 4 times ln of 5x negative 4. This is, normally this is the differentiation of dy dx. This is the differentiation of dy dx. Last three, we are going now, after getting dy dx, we are going to find, after getting now dy dx, we are going to find what is the value of this at x equal to 1. If x equal to 1, this dy dx is equal to what? Let us try it here. If x is equal to 1, you see that we have dy dx at x equal to 1, it will be equal to, we are going to substitute x here. We have 5, 2 times 1 negative 3, 2 times 1 negative 3, negative 2 times 5 times 1 negative 4 times ln 5 negative 4. We divide with 5 times 1 negative 4, which is this one, then we multiply with 2 times 1 negative 3 squared. This is equal to 5 times negative 1, 2 negative 3 is negative 1, negative 2 times 5 negative 4, 1 times ln of 1, we divide with 5 negative 4, which is 1, then negative 1 squared. So this is a negative 5. 5 times a negative 1 is negative 5. Ln of 1 is equal to what? You can guess. Ln of 1 is equal to what? It's equal to 0. So when you take a 0 multiply with this number, we get 0 divided with 1 times 1. Negative 1 squared is 1. So we get this value is equal to negative 5. You can say that dy dx at x equal to 1 it is equal to negative 5. That is the value of our dy dx depending to that function. Thank you very much. If you think this is helpful, don't forget to subscribe. Don't forget to follow my page.